Exercise 10.01, the quadratic function. So far we've been looking at straight line graphs, so linear functions, linear are straight line graphs of the form y equals mx plus b, okay? And the graphs are straight lines, whereas non-linear functions take many different forms and their graphs are curved. Now, the first type of non-linear function that we're going to be looking at is the quadratic function. Now, a quadratic function is what you know as a parabola. Okay, so a quadratic function is a non-linear function where the highest power of the independent variable, which is usually x, where the highest power of x is 2. So it'll be x squared type equations. So in the next few lessons, we're looking at parabolas, which are also called quadratic functions or quadratic graphs. They have x squared in them. So straight lines are like y equals 5x plus 3. Y equals negative 2x minus 4, right? But these are y equals x squared type graphs, so they'll always have an x squared, okay? So a quadratic function is a nonlinear function where the highest power of x is 2, so it'll be x squared. So not x cubed, they're cubics. We do them after this. And in this section we're looking at quadratic equations. It'll be something like this: y equals ax squared plus c, where a and c are different constants. And in today's lesson, we're investigating what happens if you change the values of a and c. For example, y equals 5x squared. Y equals 2x squared minus 5. We're going to learn how to draw these and to recognize them quickly. This one is negative half t squared. Instead of an x, this is a t squared plus 1. And here is another one as well. See how the highest power is squared? That is c equals 7 minus v squared, or you could write that as minus v squared plus 7. Okay, so we're going to learn sometimes in front of the squared term you can have a positive, sometimes you can have a negative. That will tell us about whether the curve is facing upwards or downwards. Okay, now, just a quick sketch of a quadratic function here. So the graph of a quadratic function is called a parabola. So if you just look at it like that, that's a quadratic function, but when you sketch it, it's called a parabola. Okay? The simplest quadratic function is y equals x squared. So what we've done over here is a sketch of y equals x squared, but we're going to go through it. So the easiest way to look at a function and sketch it is to draw a table of values. But by the end of the day, we don't want to be end of the lesson, we don't want to be just drawing table of values. We're going to know the shapes, recognize the shapes. So for example, when x is negative 3, on your calculator, if you were doing this, you have to go negative 3 in brackets squared. That's why you're getting positive 9. So when x is negative 3, if I'm substituting into the formula y equals x squared, so negative 3 squared is negative 3 times negative 3 is 9. Negative 2 squared is negative 2 times negative 2, which is 4. When x is 1, negative 1 squared, negative 1 times negative 1 is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4, sorry. 3 squared is 9. Now that's my table of values. So you know, if you ever have a function, this is the function y equals x squared. I can substitute different values of x to work out the values of y. I'm going to sketch another one on this graph in a minute, all right? So then I plot my points. So, for example, if you're given this equation y equals x squared, and by the end of this lesson, we're going to be able to recognize what those graphs look like, just by looking at pictures of them, all right? But if you had no idea what it looked like, you would substitute different values of x to work out the values of y, and they become points that you plot. So, as I said, when x is negative 3, do we get that? Y is 9. So look at the point here on the graph. This is the y-axis, that's the x-axis. I've got the point negative 3, 9. Can you see it? When x is negative 2, y is 4. I've got the point negative 2 across, 4. So plot them. When x is negative 1, y is 1. I've got the point negative 1, 1. Can you see the plots now? I've got the point x is 0, y is 0. I've got the point 1, 1. Now what you're going to notice about parabolas is that they're symmetrical. They have an axis of symmetry straight down the middle. One side is identical to the other. and it's identical where it turns. So you put a line down the middle where it turns, okay? When x is 2, y is 4, and when x is 3, y is 9. And then you would get your pencil and draw a smooth curve between those points, not straight lines that join the points. A smooth curve. So just showing a few more substitutions. Y equals -1 squared is 1, etc. Y equals 0 squared is 0. So that's just substituting x is -3, x is -2, x is -1, x is 0. Then you would substitute x is 1. Do you get it? If you are ever given any formula, you can substitute any x value you want, and and when you put the x value in, you'll get the y value out, okay? And then that becomes a point for you to plot, an xy value for you to plot, okay? Probably should have put a blank graph here, and we should have done it on our own. But we're going to be graphing more equations today, okay? For parabola, you must get that shape, otherwise something's wrong. All right, now, the only types of parabolas that we're going to look at today and that are in this course are of this type. Y equals ax squared plus c. So you might have a number in front of the x squared, and you might have a constant, okay? And that's a parabola with, so it will look like that, or it will look like this. Now, these are called, you know how that's upwards? See this? That's an arrow. That's an arrow pointing to the very bottom of the parabola is called a vertex. And the very top of the parabola is also called the vertex. Okay? This is called concave up because this parabola is facing upwards. And your parabolas can also be concave down or facing downwards. Now, you're going to learn, you know, like how for straight lines, the number in front of the x told us if the line was positive or negative. If your A here is positive, we're going to investigate this in a minute, it'll be concave up. If whatever is in front of the x squared is positive, it'll be upwards. So examples, this might be y equals 2x squared, y equals 4x squared, y equals a half x squared. They're examples of concave up. Concave down one is when the A here is negative. That might be like this, y equals -2x squared. So when the value of A, remember the general form is y equals ax squared plus c. When you've got a negative, for example, in front of the x squared, the parabola is downwards, okay? Now, again, if A is positive with this y equals ax squared plus c, the parabola is concave up. It's shaped upwards. It turns upwards. The cave is upwards. If A is negative, it's concave down, like an upside down bowl. And the turning point, see, it's like you're coming down and you reach the very bottom and then you go back up. The turning point is called the vertex. And here, you're going up and that's where you turn to go back down. So that's the vertex. Now, there is no reason why I can't add numbers onto these. I can go +3, I can go -1, it doesn't matter. Concave up is if the number in front of the x squared is positive. I can have nothing on the end. That's my +c on the end. I could have +4, I could have -1, it doesn't matter. As long as the a in front of whatever's in front of the x squared is negative. Okay? Now, we're going to do investigations on those now. All right? 4 different graphs here. One of them you can't see very well. Y equals half x squared, 2x squared, and y equals 4x squared. And we're going to label these 4 graphs and we're going to colour them in, but I'm going to use GeoGebra. All right? So I'm just going to go into that now to graph them. Not GeoGebra, but Desmos, beautiful free maths, and start graphing. And we're going to put those 4 graphs into Desmos. Use a table of values. So we're going to use Desmos first. So y equals a half. I'm just going to go 0.5 for a half. X, see that's a straight line, and I have to go squared. Okay, half x squared. See how it's a parabola? And then I'm going to go y equals 1x. That's a straight line until I make it squared. That's the blue one. So the red one is half x squared. Y equals 1x squared or just x squared. Okay. Then I'm going to do y equals 2x squared is the green one. What's happening when I make the number in front of the x bigger? Well, it gets, instead of smaller, there's another word. Thinner or steeper. And it's the same when you do straight line graphs. If you're graphing y equals x, 2x, 3x, 4x, it gets steeper. So what we've got here, now that you can see those four graphs, I'm just going to change the scale on the axes, or you can actually see the scale as well. So now I've got each graph. Now the red graph, a half x squared, it seems to be the flatter one, and y equals 4x squared is the steepest one. But we can draw up a table of values as well on the sheet that we're going to be doing. So, and we're also going to write a little conclusion. So as the number or the coefficient of, when the number in front of the x squared gets bigger, what happens to the curve? It becomes steeper. Okay, does that make sense? So half x squared is the smallest number in front of the x squared, it's the wider graph. And 4x squared is the biggest, 4 is the biggest number in front of the x squared. We've got a steeper graph. So let's go to our sheet. Half x squared is the, we're going to go for the purple, whatever. You can just do them how you want. Maybe textures are better. So I'm going to colour code in a minute, or you can write them on. But we're going to check some points in a minute, all right? So y equals a half x squared is the purple one. And, or I can put it on this side. Let's just do a table of values for one or two of them. So you can code them. Y equals x squared is the next one in. I'm just going to pause the video and you'll see it done in a minute. So y equals x squared is the pink one, etc. You might want to label it as well. All right, so that would be a good idea. Here you might want to put it up on the heading. This is of the type y equals ax squared, where a is positive or negative? Is a, where a is greater than 0, where a is positive. Aren't they called concave up? Concave up. So that's what we're looking at first in activity 1. Quadratics, which are parabolas when you draw them, of the type y equals ax squared, where a is positive or concave up. So we're going to write our conclusion now. That's our heading. Coefficient, so when the coefficient of a becomes larger, the graph, the parabola, becomes steeper. Okay, now, so when the coefficient of a becomes larger, the graph becomes steeper, and when a is positive, and we write that by saying, when a is greater than 0, the curve is concave up. So when the coefficient of, or as the coefficient of a becomes larger, you might want to say, the parabola becomes steeper. Okay? And when a is positive, or a is greater than 0, the curve is concave up. And let's just do a table of values for one of them. Which one do you want to do?
The half one.
Okay, good. So I'm going to choose, so because I'm halving, I'm not going to choose, I'm going to choose the point, I'm not going to choose, all right, I'll go -2, -1, 0, 1, and 2. So just going to choose a few values. We're just going to look at y equals a half x squared. Okay? So on your calculator, or you can do it in your head, you can do them on your calculator. It would be half times, you'd have to put the -2 in brackets and then square it. Or I'll do it now. You must do the x squared first. So -2 times -2 is +4. A half of 4 is 2. Yeah. Can you go to your calculator and do that? So on your calculator, just go half, bracket, -2, close bracket, squared. Tell me what you get. Bracket, -2, bracket, squared.
2.
Okay, and then do Cancel a half bracket. -1 in brackets, squared, you get a half. Now that's a bit of a yucky point to plot. 0 would give you 0. Now what you're going to notice is that only for this type, but when you put 1 in, it's 1 squared is 1 times a half is a half. 2 squared is 4. You don't do half of x and then square it. No, you don't. Good values to choose are from -2 to 2 for your x values. All right? They're good values to choose. So just choose those. And when x is 2, 2 squared is 4, half of that is 2. Let's just check with our plotting on the purple graph. When x is -2, y is 2. Can you see that? When x is -1, y is a half. That looks about right because that's 1. Not a really good point to plot that one. When x is 0, y is 0. When x is 1, y is a half down there. When x is 2, y is 2. And then you would draw your smooth curve. The half one's probably not a really good one to plot, but do we get the idea of substituting? Yes. What we'll do, as we do each type, and there's 3 different types we're doing, we'll do 1 substitution on each page. If you want, I'm happy for you to do some other substitutions, but please, if you're doing 2x squared, 4x squared, you don't square the 4, you only square the x squared, and then you'll times it by 4. Or you'll just put it exactly as you see it, 4 bracket.
Say if you're doing 2, so you would go 2 squared and then times that by 4.
That's right. Concave down. So they're of the type y equals ax squared as well, where a is less than 0. In other words, it's negative. They are called concave down. Okay? So they're concave down. So they are still the type ax squared, but a can be positive or a can be negative. A is just a constant. If a is negative, the curve faces downwards. All right? Now, I'm going to go into Desmos again. What I might do, see that red one there? That was the positive one. I'm going to put a negative in it. It's just flipped it down. Having a look. Y equals x squared or 1x squared. I'll put a negative in front. Same graph, flipped downwards. Reflected in the x-axis. Y equals 2x squared is the green one upwards. Negative 2x squared is down. 4x squared is concave up. Negative 4x squared is down. What I'll do, I'm going to put one of them, I'm going to put just a 2x squared on top. See, it is the same size as negative 2x squared. They're the same width. 2x squared, negative 2x squared. See how they are just reflections? Same size but turned downwards. So, wait a sec. So when we look at this, don't think -4 is smaller than -1/2. -4 is wider. It's not. The negative, you have to look at this in 2 steps. The negative tells you downwards. The 4 is still steeper. Do you get it? The 4 means it's the steeper one than 1/2. So the negative only tells you that it's faced downwards. But remember 1/2x squared, when I did 1/2x squared, the positive one was the wider one. Negative 1/2x squared is still the wider one. Look, I'll put negative 1/2x squared up there in black. And I'll put y equals 4x squared up there in some other colour apart from red. Oh, I don't know how to change the colour. Y equals 1/2x squared. Look at negative 1/2x squared, the red. Look at 4x squared, which is the purple, negative 4x squared. So still the 4s are the steepest, but negative 4 is the concave down, flipped downward version of the steepest. Do we get the idea? So, good. And our conclusions. So the type is y equals ax squared, where a is less than 0. So, if a is less than 0, in other words, if it's negative, the curve is concave downwards. Now, it's just if there is a negative, yeah. So if there is a negative in front, the curve is concave downwards. as the value of A without the negative. Don't look at the negative. The magnitude, it's called the magnitude of A. So as the magnitude of A gets larger, the curve gets steeper. For example, y equals negative 4x squared is steeper than, say, y equals negative x squared. Does that make sense? Because in front of the negative x squared, in front of the x squared there is negative 1. Yeah. So minus means facing downwards. Got it? And the 4 in front means it's steeper. Just get you to practice some table of values. I might just do the y equals negative 2x squared quickly, very quickly. So I've got negative 2, negative 1, 0, 1 and 2. So just looking at negative 2 squared is positive 4. 4 times negative 2 is negative 8. No, it's not. Yes, it is. Yeah, it is. Negative 1 squared is 1 times negative 2 is negative 2. 0 squared is 0 times negative 2 is 0. 1 squared is 1 times negative 2 is negative 2. 2 squared is 4 times negative 2 is negative 8. If we try to sketch that, I've got 0, 0. I've got 1, negative 2, which is a green one. See, 1, negative 2 is here. And 2, negative 8 is down there. Okay? And negative 1, negative 2 is there. And negative 2, negative 8 is down there. So look, the best thing is to put it in on your calculator. Negative 2, bracket. Negative 2, bracket, squared. And you will get the negative 8. On your calculator, you have to go like this. Negative 2, bracket, negative 2, squared on your calculator. That's a negative. That's not a minus. Okay?